Hi there, and welcome to University High School's summer math program here. Just trying to get you ready for high school. Today's lesson is called Solve Proportional Relationships. So it's kind of step 2. We've talked about rates already and setting something up as a fraction. So today we're going to talk about proportional relationships. A proportion is an equation that states that two ratios are equivalent. So again, we're going to take two ratios and we're going to say that they're equivalent, which means that they are equal to each other. To determine whether a pair of ratios forms a proportion, use cross products. You can also use cross products to solve proportions. So this is one way you can solve to determine whether something is proportional or not. Cross products, there are some other ways as well. Cross products is going to get us into a little bit more algebra type of work. Okay? So a couple examples here, and again the examples I just kind of run through with you just to make sure you have something to look at in case you don't want to see all my examples I'm going to do in just a second. So I'll always kind of give you the directions, some examples, and then I'll work through a couple problems, we'll pause, and then you can do your homework. Okay, and I'll give you a few solutions to homework. So determine whether the pair ratios 20 over 24 and 12 over 28 form a proportion. So again, proportion means that they're going to be equivalent, or essentially if you were to reduce them down, they're going to be the same. Okay, so they give you an example here of 20 over 24, and it says use cross products, meaning you're going to take the denominator of one and multiply it by the numerator of the other. That's what a cross product is. So 24 times 12 becomes 288, and over here 20 times 18 becomes 360. Because those are not the same, we would say they're not equal, and because they are not equal, we would say they do not form a proportion. Does that make sense? So something that might form a proportion, for example, if I had 1 over 2, and I'm wondering, does that equal, let's go with 4 over 8, just for something simple here, right? As a cross product, I would say 1 times 8 is 8. I would say 2 times 4 is 8, and because 8 equals 8, I would say yes indeed, that is a proportional relationship. So you can see how that's going to work out. Another way of looking at a proportional relationship is sometimes you can see, what do you do to 1? I think of it this way. Let's go 1 over 2 equals 4 over 8. Again, these are really just two ratios. So if the ratios are the same, then you can do something to the numerator and numerator to make it equal to the other one. So I think, okay, what can I do to 2 with multiplication or division to get to 8? So in this case here, I can think, 2 times 4 gets me to 8. Does that work up here? What is 1 times 4? Oh, it's actually 4. So if you can use the same process, multiplication division, of a number here to go from one side of the equation to the other, then you also know it's forming a proportional relationship. I'll give you some examples of that in just a second. In terms of solving a problem, the same thing is going to be applied, except now we have a variable here that we have to solve for. So you can see we have 12 over 30 equals k over 70. All right? And so just real quick, it says, okay, write the equation down. So they have you write it down, and then find the cross products. The cross products here again are 30 times k, so they write that right here as 30k, and then we have 12 times 70. This is the part where you might find a little, problemsome. You might run into a little problem having to figure out the math. Going, oh, now I have to do 70 times 12 and work that out. Yeah, you do have to do that. That's okay. And so we know 70 times 12 is 840, and then we have 30k, so there it is, 840 and 30k. And now we have to divide both sides by 30. So again, you're doing this math problem. So you're doing 840 divided by 30. And we know that goes in there 2 times for 60. And we bring that down. Oops, sorry, don't need to borrow. Sorry about that. So 24, and in this case here, 30 goes into 24 8 times. I can kind of ignore the zeros and think 3 goes into 24 8 times. So we have 28 is equal to k. Again, this is a great opportunity for you not to solve it with a calculator, but you could use a calculator to help verify that your solution is correct. In case you're wondering, did I get it right? Do it there. We want to know, do you know how to do some basic math as well? So just remember, when you take this test later on in the first week of school, you won't be able to use your calculator for a lot of these problems. Let's do some simple ones here before we move on to tonight's homework. So the homework's going to look a lot like this. So determine whether each pair of ratios forms a proportion. So if it's proportional, it's going to be equivalent, right? So we'll set them up. So the first one, we would set up 17 over 10. And we're asking ourselves, does it equal, so I can put a question mark there because I don't know, does it equal 12 over 5? And the way we go about determining that is we would use cross products, so 17 times 5. Now I don't know what 17 times 5 is, top of my head. 7 times 5 is 35, put 3 there. 5 times 1 is 5, plus 3 is 85. So does 85 equal 10 times 12 is 120? The answer would be no, they are not equal. So this one would be no, not proportional for number 1. That's all you're doing. You're proving that, or determining whether the ratios are proportional. When we look at number 3, we can see here we have 8 over 12, 10 over 15. So I'll set up the same equation. I'll write 8 over 12. I'm going to find out, is it equal to 10 over 15? So again, I can look and say, well, 12 times 10 is 120. I'm asking, is that equal to 15 times 8? 15 times 8, 15 times 8. 8 times 5 is 40. 8 times 1 is 8, plus 4 is 12. And so certainly in this case here, 120 is equal to 120. So this one would be a yes, it is proportional. So it's just a lot of math. You just want to be very careful about how you do things. Again, you could certainly do it with a calculator, but again, it's a two-step process even with a calculator, right? I'd have to multiply 15 times 8 to write down the 120. I have to write down 10 times 12, oops, 10 times 12 to show 120, and then I'm able to say, yes, it is there. So you could check your work, but you'd still want to write them down to keep the numbers in place. Let's look at a couple solving proportion problems here. So for number 10, we can see we have it already set up as an equal sign, so we know that they are proportional. The equal sign is there. The question is, what value do I have to put here to make them proportional? And like we said, there's two ways of looking at it. I can use cross products and solve for x, or sometimes I can visually look and see if there's a relationship moving from one side of the equation to the other using multiplication and division. Okay, let's take a look first of all at if there's a relationship. I need to go towards the x is what I do. So I think I want to go from 15 to x. So looking on the denominators, what can I do from 25 with division and multiplication to get to 5? Well, if I divide 25 divided by 5, I end up with 5. So if I look at 15, I do the same thing and ask myself, what is 15 divided by 5? 15 divided by 5 is 3. So my answer should be x equals 3. But let's use cross products and see if that's actually the case. So on this side, we're going to do 15 times 5. So 15 times 5 is 5, carry the 2. 5 times 1 is 5 plus 2 is 75. And that's going to equal 25x over here. It doesn't matter which side you put them on as long as they're separated, right, by the equal sign. So to get x by itself, they're joined together by multiplication. So I will use division to break them apart. So I'm breaking both sides apart by 25. 25 over 25 becomes 1, so that cancels out. We're left with just x over here. And 75 divided by 25 is indeed 3. So I end up with the same solution. Sometimes you can do the algebraic way, where you're going to use the math, set up the equation, and solve for x. But sometimes you can see the relationship between the two ratios that are forming the proportion. Let's look at number 11. Right, this is another example. Can you see a relationship here moving from the number to the variable? When I look on top, is there a relationship between 3 to 12 using multiplication or division that you can see? All right, see if you can see what that is. For me, I look and say, that looks like 3 times 4 is 12. So what is 4 times 4? It should be 16. So I should have c equals 16 as a solution. But let's just double check, just for practice here. We have 3 times c is 3c, and that equals 4 times 12, which is 48. Now to solve this, I'll divide both sides by 3 because they're joined together by multiplication. So that reduces down to 1. So we have C equals 3 goes into 48 16 times. So yes, it is indeed the case. So that does work there. Let's look at number 14 though. You can see here, I don't see a relationship there. Some people would go, oh yeah, you add 4. No, you can only multiply and divide when you're looking for the relationship. Don't think about adding. That's why I picked this one here as an example. It's a common mistake kids make. Oh, I add 4, it's 9. No, it's not. So you can only use multiplication and division to see a relationship. And there's just not one that's there. It's easy for me to recognize. So in this case here, I have to use the cross products. So I'm going to do 8s equals 12 times 5, which is 60. Now in this case here, it's a little more cumbersome. So I'm going to divide both sides by 8. So I add s equals 60 divided by 8. That's not an easy one to solve, so I'm going to have to use some long division real quick. Slide my paper over. 60, 8. 8 goes into 60. We're going to say 7 times. 7 times 8 is 56. We subtract and we have 4. Alright, I'm not quite done yet, so I'm going to put a decimal and add a 0 placeholder. Satellite dish up on top right away. Bring down the 0. 8 goes into 40. 5 times 8 is 40. No remainder. So s is equal to 7.5. Alright, so sometimes it's a quick relationship and you can solve it simply. Other times it might take a little bit more work, but again, you could always check it with a calculator to verify. But we want to make sure you can do it without the calculator. So make sure when you do the homework that you're practicing that. Your homework here is going to be to do the odd problems on page 6.6. Alright, so the odd problems here. And I'm going to go ahead and do some of the solutions for you in just a few minutes. I'm going to be working on numbers 1, 7, 11, 15, 19. I'll give solutions in a minute, so you go ahead and pause the video, do your homework, and then come back and check. Okay, here we are. We are back. All right, so we're first of all going to find out if these quantities are proportional. And again, proportional means are they equal? That's what we're trying to figure out here. All right, so for the first one, number 1, do I see any relationships here? Going from one to the other, let's see. Well, 5, if I go think big to small, 5 to 15 is multiplying by 3. So this is proportional. I multiply this by 3 and get the same number. What is 9 times 3? 9 times 3 is 27. So because what I'm doing to the top and the bottom is the same, times 3, and I get the other side, this tells me the answer is more than likely going to be yes. Now, you might have solved it using cross products here, and that is just fine. So I could do 15 times 9, which is 5 and 4. 9 times 1 is 9, plus 4 is 135. And then over here I have 5 times 27. So I can write 27 times 5. 7 times 5 is 35. 5 times 2 is 10, plus 3 is 135. And indeed, those are equal. So we would say yes. So again, 2 ways of doing it. You might be able to visually show that it is and prove it, but you need to be able to at least demonstrate why, not just say yes. If your answer was just yes, I probably would need a little bit more on a test to verify that you know what you're doing there. Let's look at number 7. Okay, for number 7, when I look at this one, I'm going to zoom in a little bit here. I think we go one more. There we go. I don't see a simple relationship between these numbers. I can't think of 14. 14 times 2 is 28, so that's not going to work. So there's not a simple thing to see. So I'm going to need to use cross products. So for the first one, I can do 14 times 35. I'll do 14 times 35. It doesn't really matter which one you put on top or bottom when you do your multiplication. I'm going to use the 5 just because I like multiplying by 5. So 5 times 4 is 20. 5 times 1 is 5, plus 2 is 7. We need a space holder here for the next one. 3 times 4 is 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. So we end up with 490 on this side. And we're trying to see if that's equal to 17 times 29. Again, a nice problem for you to check with a calculator if you wanted to. I probably would check with it because sometimes I make little computational errors. 9 times 7 is 63. 7 times 2 is 14, plus 6 is 20. Space holder 0. 1 times 9 is 9. 1 times 2 is 2. Add that up, we have 3, 9, and 4. And so in this case here, 490 does not equal 493, so that is not going to be proportional. So we would say no, it's not proportional. All right. And again, you do the same for the other ones. You could always, like I said, check it with a calculator if you need to. Let's look at number 11. I wanted to do 11 because it's a decimal, your favorite things. Okay, do I see a quick relationship between 8 and 6? Not really. Between these and those? Not really. So I'm going to have to do the multiplication cross products here. So I'll do 4.96 times 6 on one side. Then I'll also do 3.72 times 8 on the other side. And we're trying to decide if these two are going to be equal. So 6 times 6 is 36. 9 times 6 is 54. Plus 3 is 57. 6 times 4 is 24. Plus 5 is 29. I can see up here in my equation I have 2 behind the decimal. So I'm going to need to hop 1, 2, put a decimal point there. 8 times 2 is 16. Carry the 1. 56 plus 1 is 57. 24 plus 5 is 29. Again, I have 2 digits behind the decimal, so I'll hop here 2 places. And 29.76, they are equal, so we would say yes, those are proportional. All right, let's look at a couple solving proportions here. In the last section, there are 5 to do here. Again, sometimes you could look for simple relationships, like I see one here, 13 to 26 looks like a times 2. So maybe you saw that, maybe you didn't. Let's look at 15. For 15, I don't see a relationship between 3 and 5 that multiplies, divides easily. So I'm going to use cross products. So I'm going to take 5 times u, which is 5u, and make that equal to 15 times 3. 15 times 3 is 45. Now to solve for u, it's joined together by multiplication, so we'll separate it with some division. So 5 divided by 5 is 1, leaves me with just a u right there. And 45 divided by 5 is equal to 9. So for number 15, u equals 9. All right, 17 you did on your own. You can check with a calculator if you like to. Here, I don't see a real easy relationship. There is one, but you may not see it there, but that's okay. So let's go ahead and use cross products. So we'll start here. We'll do b times 0.1, so we end up with 0.1b equals 8.2 times 1.8. I wrote it out like that because I don't know what that is quickly. So I'm going to have to use some kind of scratch paper off the side just to figure that one out. So I'll do 8.2 times 1.8. 8 times 2 is 16. 8 times 8 is 64, plus 1 is 65, 0 there. 1 times 2 is 2, 1 times 8 is 8. We'll add that up. 6 plus 0 is 6, 5 plus 2 is 7, 6 plus 8 is 14. I have 1 digit behind his decimal and another one, so I have 2 digits behind a decimal. So I'm going to hop over 2 spaces and write down, 14.76. Yep, double check that with my calculator here. 8.2 times 1.8. And we have 14.76, just like that. So we're going to say 0.1b equals 14.76. Now, in order to get the b by itself, I have to divide both sides by 0.1. 0.1. Again, probably something you don't really want to do, because having to divide decimals. That's why I chose this one here, because you won't have a calculator when you do a test the first week of school, okay? So, we know this is going to cancel out. We're left with b. Let's see what we have here. Well, 14.76 gets to live inside the house, right? 0.1 is on the outside looking in. Okay, so now how do we solve this? Well, we're going to move the decimal over here one space. So now we have 1. Okay, I'll shade that out, not worried about it here. If I move the numerator's decimal, or the denominator's decimal over by 1, I need to move this one over by 1 and immediately put the satellite dish up on the top. Okay? Good so far? Alright, so 1 goes into 1 one time. Bring down the 4. 1 goes into 4 4 times. Bring down to 7. 1 goes into 7 7 times. Bring down to 6. And 1 goes into 6 6 times. And we're 0. So my solution for this one is 147.6. And that was really long. Totally get it, right? Like, can I use a calculator? Yeah, you could, but again, just want to see if you were able to do the math part here. So in this problem here, I'm checking a lot of things. I'm checking to see, do you know how to multiply 2 decimals? Do you know how to divide 2 decimals? So those are some of the other things we're looking for at UHS when you're here. It's great that you can use a calculator, but do you know how to do some math? Because not always do we have a calculator handy. You'll need to do something like this when you're doing your physics work and your chemistry work, and especially physics this upcoming year. So make sure you can do the math. All right, that's it for today. Have a great day, and we'll see you next time.